Today's lesson objective, students use algebraic properties in logical arguments. So we have some algebraic properties that you actually already know, you just haven't thought of them as properties that you would have to explain your work. But you know all these from algebra. These are all properties that you use when you're solving algebraic equations. So the first one, for real numbers a, b, and c, we have the addition property. If a is equal to b, then I know if I add the same thing to both sides, a plus c would have to equal b plus c. It just says if you add the same thing to both sides, they're still equal to each other. And the subtraction property is almost the same thing. If a is equal to b, then a minus c is equal to b minus c. Again, as long as you subtract the same thing from both sides, they're still going to be equal to each other. The multiplication property, if a is equal to b, then a times c is equal to b times c. And the division property. The division property, if a is equal to b and c is not equal to 0, and they say that because you can't divide by 0, so if c is not equal to 0, then I know a divided by c is going to equal b divided by c. And this last one, the substitution property, that's one that you probably haven't used in Algebra 1 very much, but we will be using it a fair amount in our proofs. If a is equal to b, then a can be substituted for b in an equation. A can be substituted for b in an equation. In other words, wherever a was, we can put b in instead. All right, so we have an example here. We're going to use the properties of equality to justify each step to solve the equation 2x plus 5 is equal to 20 minus 3x. Okay, the main thing that messes people up on these is they need to remember to write the reason after the operation. So you're going to write the reason after you perform the operation. Okay, don't tell me what you're going to do, tell me what you did. Okay, so if we look on the left side, we've got all the steps to solve the equation, and on the right, we're going to write our reasons. So the first step, we've got 2x plus 5 equals 20 minus 3x. Okay, well, nothing's been done to it yet. That's just what we were given. And so given would be your reason. And then if we look at the next step, now we've got 5x plus 5 equals 20. So I asked myself, okay, what did they do when they went from step 1 to step 2? Well, they added 3x to both sides. So that means they used the addition property of equality. Now, you don't have to write out all the words addition property of equality. You can just write addition and then put an equal sign in parentheses, and then I'll know you mean the addition property of equality. Okay, so now I look at when they're going from step 2 to step 3. Now I have 5x equals 15. So what did they do? It looks like they subtracted 5 from both sides. So what lets you do that? The subtraction property of equality. And then finally, if I look at the last step, what did they do? They divided both sides by 5. And what allows me to do that? The division property of equality. And so there you have your first basic proof. It's an algebraic proof, but a proof nonetheless. Another property that you're going to use is the distributive property, and you've used it in the past in algebra. A times the quantity b plus c is equal to ab plus ac, where a, b, and c are real numbers. So, for example, we're going to solve negative 4 times the quantity 11x plus 2 is equal to 80, and we're going to write a reason for each step. And again, I'm going to write the reason after I do the operation. So my first step, I've got negative 4 times the quantity 11x plus 2 is equal to 80. My reason is just that it was given to me. And then if I look and see, well, when they went from Step 1 to step 2, what did they do? Well, I can see that they distributed the -4 into the parentheses, and so that would be the distributive property of equality. And then if I look at how they got to the next step, what's different? Well, I don't have the -8 anymore. It looks like they added 8 to both sides, so that's the addition property of equality. And then finally, the last step, they divided both sides by -44, and so that would be the division property of equality. All right, we also have some other properties that we're going to use in geometry, and the first one is the reflexive property of equality. So for real numbers, for any number a, I know that a is equal to a. And so in a sense, a is looking at itself in the mirror. So if you think of reflexive as kind of like reflection. Okay, so that can hopefully help you remember that when you see a equal to a, whenever you see something equal to itself, just think, oh, hey, it's looking at itself in the mirror, and that's the reflexive property. All right, and so if we're talking about segments, then for any segment AB, I know the segment length AB would have to equal AB. And again, when we're talking about lengths, we don't put the line over the notation. AB means the length of segment AB. And then for angle measures, for any angle A, I know that the measure of angle A is going to equal the measure of angle A. And that's the reflexive property. The next property we'll talk about is the symmetric property of equality. For real numbers, if A is equal to B, then I know B is equal to A. And so what happens with the symmetric property is that they switch places. And again, every now and then you may need this in a proof because it's not in the right order for what you need, and so you have to essentially flip it over, and so you use the symmetric property to do that. When we're talking about segment lengths, if AB is equal to CD, then I know CD is going to have to equal AB. And for angle measures, if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. Okay, so symmetric, switch places. They both start with an S. Next we have the transitive property of equality. What the transitive property says is if A equals B and B equals C, then A equals C. And you can use the transitive property to have an even longer chain than that. You can have if A equals B, and B equals C, and C equals D, and D equals E, then A equals E. So essentially you can make a small train. So think of a train, transitive. Okay. All right. So if we're dealing with segment lengths, then if AB is equal to CD and CD is equal to EF, then I know that AB would have to equal EF. So essentially, we're taking out the middleman. And for angle measures, if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then I know the measure of angle A would have to equal the measure of angle C. Okay, so you will have some problems on your assignment where you have to identify the property. So I'm going to show you some examples, and I want you to pause the video as we go over each one to see if you can come up with your own answer, and then check to see if you got it right. So the first one, if x equals y, then y equals x. Stop and think for a minute what property you think that might be. Okay, so that would be the symmetric property. They switched places. If I look at what changed from the if to the then, all that changed was they're in a different position, and so that's the symmetric property. The next one we've got, if x equals y, then x minus 7 equals y minus 7. So think for a minute what you think that might be. All right, so if you look at it, here's what I started with, if x equals y, and then when we came to the then, now I have x minus 7 equals y minus 7. So what changed? They subtracted 7 from both sides. So that would have to be the subtraction property of equality. And the third example, if x equals y and y equals 3, then x equals 3. So again, just looking at where we started with x equals y and y equals 3, and we ended with x equals 3. So what did they do to get from the if to the then? Which property did they use? Well, we took out the middleman, or we've got a train, or however you want to think of it. It's the transitive property. Transitive property of equality. All right, so now we're going to do a two-column proof. In the diagram, AB is equal to CD, and we are going to show that AC is equal to BD. So they already have the steps written out for you as far as, the order of the steps, but let's just think about it logically for a minute. I know that these two pieces are congruent to each other. And if I look at it, both AC and BD have BC as part of them. So all we're doing is AC is having this little yellow piece on the left added on, whereas BD has the same size piece being added on to the right side. So since we're adding the same length onto the same piece, it makes sense that they are equal to each other. So that's what we're going to show step by step in a logical progression. So my first statement says AB equals CD. And I know AB equals CD because they told me that. Up here, they said AB was equal to CD, so that was given to me. That's information that they gave me. All right, the next one, the next step, says that AC is equal to AB plus BC. So that's saying this whole thing, AC, is equal to this piece plus this piece. So if you think back to chapter 1, when we talked about the pieces adding up to the whole thing, there were two postulates where we said that was the case. The segment addition postulate and the angle addition postulate. Well, are we dealing with segments or angles here? These are segments, so that would be the segment addition postulate that allows us to say AC is equal to AB plus BC. And now I look at my next step, and it says that BD is equal to BC plus CD. So again, the two pieces are adding up to the whole thing. That's also the segment addition postulate. All right, now let's take a look at this next step. We have AB plus BC is equal to CD plus BC. So we started in step 1 with AB equal to CD. Well, we still have AB equal to CD on step 4, but what have they done? They've added BC to both sides. And so that is the addition property of equality that lets you add the same thing to both sides and have them still be equal. Addition property of equality. And then finally, now somehow they got from AB plus BC equals CD to B plus BC down to AC equals BD. So how did they do that? How could they, instead of writing AB plus BC, write AC? Well, up here, here's AB plus BC on step 2, and they said that that was equal to AC. So wherever AB plus BC is, I can write AC instead. And if you look at step 3, they had BC plus CD, which is right here, BC plus CD. It's just written in the other order, but it's the same thing. And that equals BD. So instead of writing CD plus BC, they wrote BD. So they put something in place of something else. They substituted. That is the substitution property of equality. And this concludes the video. Thank you for watching.